All right, let's start slowly working our way through this. I need everybody's attention up here. One of the things that I want to point out real quick, because there's been a little bit of confusion, so I'm hoping to clarify. On Monday, we had a formula that looked like this. And that was an exponential growth formula for populations. Here, we're using an exponential growth function specifically for money. And I want to make sure that we're relating the pieces where they go and what they mean. There is a difference between the capital A in this formula and the lowercase a in this formula. They're both letters A. One's capital, one's lowercase, and they have different meanings because of that. These pieces right here, the A and the f of x, this means some future amount of money or some future population. So this is a future amount back here. So on our exponential growth formula for populations, that's represented by f of x. Here it's represented by that capital A. What does the P here mean again? Why did they use the letter P? It means principal. What is principal? The starting amount. Up here in this formula, they use a lowercase a, but in both cases, that means our starting amount. In the formula in red, we have R. What does R mean? Rate. Which variable in the one up on top means rate? The K. This is the rate. And the T is exactly the same between the two formulas. So we still have the future amount at the end. It does not matter which way it's represented with which variable. After the equal sign, the first thing you see is the starting amount. Then we see E. Then the rate is part of the exponent, and the time is part of the exponent. So far, so good? All right. Before we even get to part A, I want to fill in what we know. So only looking at the stuff that's in bold here, nothing else. Do we have a future amount, something that's off in the future here? No. So I'm going to leave that capital A. Do we have a starting amount that's given here? Yes, what is it? 5,000. That is our initial or starting amount. What do we put in the place of E? E. E is a number, so we just leave it as E. Do we have a number that we can put in for R? Yes. What would we put in for R? Yeah, 0.04. Remember, to make that percent sign cancel out, you have to divide by 100%. That makes that percent sign cancel. And so we do 4 divided by 100 gives us 0.04, and that's our value for R. So e to the power of 0.04. Be careful here. Just looking at what's in bold up at the top, do I have a number that I can put in for t? No, so I leave that as a t. All right, I'm going to copy this now, because we're going to use this for both parts A and B. Each piece, part A and part B, gives me a different piece of information. What additional information was I given in part A? Time. 10 years. So we're going to sub this in for T. So I would have A equals 5,000. E to the power of 0.04 times 10. What are we going to be finding by doing this? How much money will you have? Do you have it yet? No. So you're going to find a future amount. Which variable means a future amount? A. In this formula, yeah. In the other one, it's f of x. Same exact meaning, though. It's that piece that's all alone on one side of the equal sign. Is the thing we're looking for isolated on one side? Yes. Then we can take all of this right here and put it in your calculator. $7,459.12. A is approximately $7,459.12. If that is not what you got on your calculator, type it in again. If you still don't get that, show me what you have on your calculator so I can help you get the right answer. You have an extra 0 up here with this. It's 0.04 instead of 0.004. So that's why it's different. Right? Yes, there you go. All right. Yes, ma'am. You have to push the second button here. Let's get rid of that second ln. Now you get the E. For any of the things in green, you have to push the green second button. Any questions on part A? Yes, you may. Any questions on part A? All right, then let's move on to part B. Part B is an entirely different question. I'm still using the information that was in bold. So I have this. What question are we asking now?
How long would it take to double?
How long? If I ask a how long question, what am I looking for? T. Find time. T. So that's my variable that's going to stay. That's what I'm looking for. How long will it take you to double your money? We're going to find T. We're not doing some guess and check. What is double your money? 10,000. This is 2 times the 5,000 that you started with. So that would be 10,000. Do you have that 10,000 right now? No. So where would it go here? The A, because it's a future amount. So I'm going to put 10,000 in the place of the A. Rate is exactly the same because they gave us that information up at the top. So 10,000 equals 5,000 E to the 0.04 T. T is what we're looking for here. Up here, the thing that we were looking for was isolated on a side, so I could put all the rest of this in my calculator. We're looking for T this time. Is T isolated on one side right now? No. it has to be isolated on one side. Close, yes. Where is t right now? It's part of the exponent, right? When it's part of an exponent, I have to isolate the exponent in the base. So the very first thing I'm going to do is isolate this right here. That means I have to get rid of the 5,000. What operation will get rid of that 5,000? Division, because 5,000 is being multiplied to the e right here. So we're going to divide 5,000 on both sides. It is 2. Does anybody see a relationship between what we got over here and what the problem asked me to find? Double your money. When we divided, when we isolated, we got a 2 over here. What do you think you would see over here if that had said triple your money? You would have had a 3 right here. All right, have I isolated the base with its exponent? Then what do we do after that? How do I get an exponent on a side by itself? What form is it in right now? Turn it into log form. Yes, we're going to rewrite in log form. What does log form have to start with? LOG. What comes after the G? The base. What's our base? E. What comes after we do LOG and the base? The 2. What do we call that 2? The argument. So log base E of 2 equals what? 0.04t, the exponent. Here's the exponent. Here's the base. Here's the argument. Do we have a better way of writing log base E? ln. I'm going to bring my work around here. ln of 2 equals 0.04t. What do I still need to do yet to get t all by itself? Divide both sides by 0.04. And t comes out to be ballpark. Give me out to 3 decimal places. $17. 328, 17.329. I'd take either one of those. If you take it out to 4 places, I'd take that too. What is t? What did we just find? Time. Time usually has units with it, right? To double the money in a bank, do you think it took 17 hours, days, weeks, months, years? Years.
So like 17. So I just put 18.
It's not 18 though. You got to take it out. You have to follow the process of using, like rewriting it as a log to solve this problem. We're not using guess and check on that one. Okay? Using guess and check, you could narrow it down. You know what it's in between. But you have to do the work like this. This is what we learned how to do in this module. This is what logs are for. They're designed to find exponents. Does that make sense? All right, go ahead and pull out your review. When is the test? Friday. Let's start rocking through this review. First question should be pretty quick, even though we've got 6 parts to it. We want to find the base on the common logarithm. What is the common logarithm? What does it look like? LOG. Base 10, yes. So my answer on part A is just 10. Part B is almost the exact same question. We still want the base, but do I want it on the common log this time? Nope, I want it on the natural log. What does the natural log look like? ln. What's the base of ln? E. Part C, is that written in log form or exponential form on part C? Log form. We're going to rewrite it into exponential form. So I have to identify the base. What's the base here? 7,776 is our base. So I start off with that number, 7,776. What do we call the 36 right here? The argument. Where does that go when it's in exponential form? Goes on a side by itself. It's after the equal sign. So what do I do with this 2/5 then? That's the exponent, yes. 2/5. What form is part D written in? Exponential form, and we want to write it into logarithmic form. Logarithmic form has to have what 3 letters? LOG. What comes after the G? The base. Right after the G is our base, which is 27 right here.
And then the argument is 81.
And then the argument of 81. And then the exponent is 4/3, and that goes on a side by itself. Remember, logarithmic form exists to get the exponent on a side by itself. All right, parts E and F are exactly what we just did in C and D, except instead of doing it with numbers, we're going to do it with letters. What form is E written in? Exponential form, and we want to rewrite this into logarithmic form, which means it has to start with log, LOG.
And then base at the, next to G.
Yep, base next to G. What's the base? B. What would come after the base? The argument. What's the argument? A. And that's equal to P. Log form gets the exponent on a side by itself. What form is part F in? It's in log form. We want to rewrite this into exponential form. First thing I need in exponential form, just like first thing I need in log form, is the base. What is our base? B. What does the A mean? Argument. Where does the argument go? After the equal sign. What's my exponent then? P. B to the power of P equals A. Do you guys have any questions for me on number 1? Cool. We're going to go look at number 2 next. What are we doing in number 2? Expanding the log. Yep. All right. When we expand, we have to use our properties of logarithms. What's the first property that we use when we're expanding? Quotient. After the quotient property, we use which property? Product property, and then powers. How do I know if I need to use the quotient property? Yep, if there's division in the argument. How do I know if I need to use product property? Multiplication, yes ma'am? Yes. If there's multiplication in the argument. How do I know if I need to use the powers property? There's exponents in the argument. All right, so let's start this. Part A, we're starting off with the quotient property. Do I need the quotient property?
Yes.
Yes, because there's division in the argument. All right, so I'm going to have log base 4 of what? 2x to the 4th. Instead of division, what does this turn into? Subtraction. Think about when we have division and we're doing exponent stuff, what do we do with those exponents? We subtract them. All right, so log base 4 of 2x to the 4th minus log base what?
4.
Base 4 of what? Y to the 5th. All right, we've used our quotient property. We are ready for the product property. Do I need the product property? What are we looking for? Multiplication in the arguments. Does this first argument have multiplication in it? Yes. What's being multiplied? The 2 and the x. Does the second argument have any multiplication? No. So this is going to be log base 4 of what? 2 plus, the multiplication turns into addition, log base 4 of x to the 4th. And then I bring this other one down, minus log base 4 of y to the 5th. So far, so good? Last but not least, we have our powers property. Do I need the powers property? Yes. Because you see what? Exponents in how many places? 2 places. This exponent, this 4, is going to come down in front of this log, so it's going to go right after the plus sign. This exponent, the 5, is going to come down in front of this log, so right after the minus sign. So fully expanded, I've got log base 4 of 2 plus 4 log base 4 of x. Yes, minus 5 log base 4 of y. That is fully expanded. So far, so good?
Not yet.
Cool.
Oh, yeah.
Part B. We always start with quotient property. Do I need quotient property? No, why not? There's no division in the argument, so we're going to skip this. No division in the argument. Do I need the product property? Yes. Looking at this argument, how many things are being multiplied together? Where do you see multiplication?
3 to x to the second power.
Yep, 3 and x to the second power,
And x to the second power.
and x to y. So 3 x squared y to the 4th. We have 3 things being multiplied. Why do I care about that? What information does that give me? Why do I want to know that it's 3 things being multiplied? I add what? How many things do I have to add?
3.
3. So how many logs do I need?
3.
3.
So 1, 3, 5, 3 plus
Yes. Log base 5 of 3 plus log base 5 of x squared plus log base 5 of y to the 4th. Is it fully expanded? No. Last step, Powers property. Do I need Powers property? Yes. Because you see two exponents. This 2 right here on the x comes down in front of this log, so right after the first plus sign. This exponent of 4 comes down in front of the last log, so after the second plus sign. So fully expanded, log base 5 of 3 yes, plus 2 log base 5 of x plus 4 log base 5 of y. That is fully expanded. Number 3 says we're going to evaluate these without a calculator. Evaluate meaning
The first one -3.
close. Very close. Means we're going to find what this is equal to. What goes on a side by itself when we're in log form?
I mean, the exponent.
The exponent. So when we are evaluating these, we are finding exponents. All right, so if I'm trying to find the exponent and it says I can't use a calculator, I'm going to kind of work backwards here. What's the base on part A? 9. I don't know what the exponent is. That's what I'm finding. And that would be equal to what? 1 over 81. It is -2.
Oh, the 9 squared.
9 squared is 81, and because it's a 1 over, it has to be a negative. Yes. All right, let's try part B. What's my base? 4. We're looking for the exponent, so I don't know what the exponent is, and it equals 64. 4 to what power gives you 64? 3. What's the base on part C?
Isn't it 10?
10. 10 to some exponent gives me what? Gives me 1. What's the exponent? 0. Yes. Anything that's on the review is fair game for the test. You can use a calculator to check your answer, yes. Absolutely. You can put that exponential in to make sure that you get the argument back out. When it says evaluate without a calculator, what they're saying is like, we're not using change of base formula here. We're not going about it that way. These are things that come out to be nice, pretty whole numbers or easy to work with fractions. What's the base on D? E. If you look up at number 1, we talked about what's the base of common log, what's the base of natural log. Base of natural log is E. We're looking for the exponent, and it's equal to what? What's my argument here? E. E to what power gives me just E? 1. Next to last one. What's the base on part E? 7. We're looking for the exponent. And that would be equal to 1. 7 to what power gives me 1? 0. And very last one. What is the base on part F? 10. Logs find exponents, so we're looking for the exponent. 10 to what power gives me 1,000,000? Does anybody know their trick For powers of 10. You count the zeros. How many zeros do we have? 6. This would be 10 to the 6th power. Do you guys have any questions on number 1 or on number 2?
No.
Cool. We talked about number 1, number 2, or number 3? Are we good? All right, let's look at number 4, bottom of the page. What are the directions on number 4? Condense. Number 2, we were expanding. Quotient, product, powers. This is what expanded form looks like. Condensed form looks like what we started with here. So we're going to be going backwards through this whole thing, which means I start with what if I'm condensing?
Power.
Start with powers, and then we go to product, and we end with quotient. So if I am condensing, we start with powers, then we go to product, and we end with quotient. All right. We talked on the expanding for like, what am I looking for? Thank you. This will be when we have our stretch. Back when we were expanding, we talked about what we were looking for in each step. So we're going to be going backwards. We're looking for something different if I'm reversing this process. In the power step, we brought the 4 down in front and we brought the 5 down in front, right? So what would I look for in the power step if I want to go backwards? Numbers in front of the logs, yes. So power step. Look for number in front of logs. All right, so let's go ahead and do that on this one because I heard you start on that already. What numbers do we have in front of logs on part A? 5 and 7. Where do the 5 and the 7 go? Yep, so this is going to be log base 2 x to the 5th, log base 2 w to the 7th. Plus log base 2 of w to the 7th power. All right, that brings us to our product step. I want to go back and look at what we did before because we're going to be working backwards. Product step. What did we do in the product step? What were we looking for? We were looking for multiplication, and it turned into addition. So if I go backwards, I'm looking for, I'm going backwards. Yes, I'm looking for addition, and it'll turn into multiplication. So product step, look for plus, turns into multiplication. Do you see any pluses? Yes. Here's a plus sign. So what am I going to be multiplying? We said it turns into multiplication. What actually gets multiplied? X to the 5th and w to the 7th. These things get multiplied together. So I would have log base 2, x to the 5th, w to the 7th. The only one we haven't talked about yet is what? Quotient. When we were expanding for quotient, we looked for division, and it turned into what? Subtraction. Now I want to go backwards, so what am I looking for? Subtraction, and it will turn into division. Look for subtraction. turns into division. You are right. There is no subtraction here. So we are going to skip this. No subtraction between logs. So what does my fully condensed expression look like? Yep, this guy right here is fully condensed. All right, part B. We start with what?
The power.
Start with Powers property. Do we need to use it?
Yeah.
On what numbers?
8 and 3. The heck?
What numbers are going to become powers?
3 and 2.
3 and 2, there we go. 3 becomes an exponent on the x. 2 becomes an exponent on the 3. So I'd have natural log of x cubed minus natural log of 3 squared. What step comes next?
The product.
Product. How do I know when I need to use product property when I'm condensing?
Subtraction.
I look for product property. What am I looking for here? Plus. Do we have a plus? No. So I skip this. Skip. There is no addition between logs. Finally, quotient property. Do I skip that one?
No.
No, because you see?
Subtraction.
Subtraction. Subtraction turns into what? Division. Where do I put the x cubed?
On the top.
On the top. Where do I put the 3 squared?
On the bottom.
On the bottom. So I have natural log, and then I have a fraction. I have division. X cubed over 3 squared. Fully condensed. Hold on. Can anybody tell me another way to write that answer that's still correct? Not x over 3. X to the third over 9. You could write it as x to the third over 9, because 3 squared is 9. Yes, sir.
I'm doing one more problem, so I gotta read the question.
You can run to the restroom. We'll do another one like this either today or tomorrow. All right. Number 5. I know it's way down at the bottom of the screen. I'll try to pop it up higher when I'm done writing stuff. The graph of a logarithmic function of base 4 has a vertical compression of 1/2, a vertical asymptote of x equals -9, and has been shifted down 3. Write an equation for this function. What are they telling me when they say it has a vertical compression of 1/2?
The A.
That's the A value. It says it has a vertical asymptote of x equals -9. What are they telling me there?
That's the H.
That's our H value. Been shifted down 3. That's our K value. All right, now I get to the end of it. Write an equation. What does an equation have to have in it, or else it's not an equation? Has to have an equal sign, right? F of x or y equals. You have to have something equals, and then we write our log function. I'm going to write y equals. You are welcome to write f of x equals. Means the exact same thing. What comes right after the equals sign? 1/2, our A value. What do I need after the 1/2? log, L-O-G. What comes after the G? I thought I heard something, but I couldn't make it out. 4, yes. Base of 4. So after the G, I put a little 4. Then our argument, we put parentheses around the argument, and this is going to be x. And then we need h or k? H. Do I put h in the equation? You put the opposite of h in the equation. What was our h value? -9. So what's the opposite of that? +9. The opposite goes here. And what goes at the very end? K, which is -3. All right, a little higher on the screen for you there. There we go. Can you guys see it okay now? Okay. So far, so good? You guys have any questions for me about this? Remember, equations have to have equal signs. So it's something equals. Y equals f of x equals.
Is the opposite like already like, or do you have to do it like when you graph it? Do you have to do like instead of +9 it's -9?
When you graph it, the vertical asymptote would be at -9. So whatever you see in the equation, h is really the opposite. So if they tell you what h is and they ask you to write the equation, you have to make it the opposite. All right. Let's do number 6, and then we'll call it a day. You guys okay with that? All right. What do they want me to do in part A? They want me to graph this right here. This is the parent. We got to make our exponential table first. All right, so exponential table, which we will flip for the parent log. All right, so here's my table. X on this side, Y on this side. For the exponential table, what do we pick down the X side? -2, -1, 0, 1, and 2. On the Y side, I have to know what the base is. What is the base of the parent log? 3. So it's going to be base to the power of -2, base to the power of -1, base to the power of 0, base to the first power, and base to the second power. What is 3 squared? 9. What is 3 to the first power? 3. What is 3 to the 0 power? 1. What is 3 to the -1? 1 over 3. What is 3 to the -2 power? That one's 1 over 9. We're going to flip this for the parent log. So these are my x's for the parent log. Yeah, we're not going to graph this. We're going to flip it. This over here, these are the y's for the parent log. So I'm going to come over here to this table. X on this side, Y on this side. My x's are 1/9, 1/3, 1, 3, and 9. So what goes down the y side? -2, -1, 0, 1, and 2. We took that pink table and flipped it around. The exponential table gets flipped for the parent log. Let's go graph that. We don't graph the pink one. That's an exponential. We're supposed to graph the log. So down the x side, this tells me how far left or right to go. My first x is 1/9. Is that positive or negative? Positive, so I have to go to the right. Is 1/9 very big? So I don't go very far to the right at all. And then I go down 2 because the y is -2. My next x is 1/3. Is that positive or negative? Positive, so I have to go to the right. Is 1/3 very big? So I don't go very far to the right. And then the y is -1, so I go down 1. So right here. Then I get into these whole numbers. 1, 0, 3, 1, and 9, 2. Remember, it does not cross the y-axis. So it lays flat against the y-axis, and then it curves through these points here. Come on. Arrows on both ends because it keeps going on forever. This is my parent. Then our transformed function. I think I'm going to do this in bright green. This is my transformation. First, we want to describe this transformation. What is the a value on this transformation? 1. Yes, ma'am. Yes, you may. Right here is where the a value would be. A is 1. If you multiply by 1, will it get bigger? Will it get smaller? Will it reflect? Stays the same, so I don't write anything about it because it's not different from the parent. So there's my a value. What's my h value? -4. This right here is the opposite. So h is really -4. Is that different from the parent? Yes. What will that do to my graph? Shift it to the left. So we're going to go left 4. And what's that piece on the end, the 1? That's our k value. What's that going to do to my graph? Shifts up 1 because it's a positive 1. Vertical asymptote. Which way does a vertical line go? Show me with your hands. Like this. If it goes like this, what axis does it have to go through? The x. So this is x equals.
The horizontal is y, vertical is x.
Yes. X equals what? The h value. What is our h value? -4. Let's go graph that. I'm going to go to -4 on the x-axis. That's right here. And we're going to go up and down. We're going to go vertically through that. So here. Guys, please don't forget these graphing problems are usually big money points because there's a lot of things to do on them. This was kind of the make it or break it question on the last test. You have been asked to not just state, but to graph that. So we have to include it on the graph. All right. Let's graph this transformed function. Which things affect my x values? Would that be left, right, stretches, compressions? Left, right? That's which value? X, h. We take h, add it to the x's. So I'm taking -4 and adding it to each of these things. So that's what I do to get my new x's. You guys okay if we start at the bottom and work our way up?
Yes.
Let's start with the whole numbers. -4 plus 9, 5. -4 plus 3, -1. -4 plus 1, -3. -4 plus 1/3. Close. It's a -4 and a +1/3.
Do you turn 4 into a fraction?
You can. It's -3.67. Because we're subtracting, like we're going to take away 1/3. It's going the opposite direction, 1/3. -4 plus 1/9 is going to be even closer to -4. This is -3.89. I popped it in my calculator. It came out as a fraction. What button do you push so that it stops being a fraction? The arrows. All right, so there's all my new x's. On the y side, what kinds of things affect y? A, H, or K? Which pieces affect y? K and A. We always multiply by A, and then we add K. What was our A value? 1. If I multiply these things by 1, do they change? Nope. That's why we didn't describe any kind of a stretch or a compression, because if I multiply by 1, nothing changes. What's our K value? 1. Now I'm adding 1 to things. That will make it change. These are going to be my new y's. -2 times 1. -2 times 1 is -2 plus 1 is -1. -1 times 1. -1 plus 1 is 0. 0 times 1 plus 1. 1. 1 times 1 plus 1. 2. And 2 times 1 plus 1. 3. We're going to go and graph those numbers. Let's start with the whole numbers first, because that's easier. Yep. Yes. Yes, you may. 5, 3. 5, 1, 2, 3, right here. -1, 2, right here. -3, 1, right here. Am I allowed to cross that vertical asymptote? Are we allowed to cross the vertical asymptote? No. It is a barrier that keeps me from going across. So my next 2 points are going to be really, really close to that asymptote. I'm not allowed to cross it. Lays flat along my asymptote and curves through these points. This is my transformation. Last thing we have to do is state our domain and our range. And then we're done. Domain is telling me about the x's or the y's? X's. Can I go in both directions forever on this transformation?
Yes.
Nope. I got this barrier right here. I'm not allowed to cross that. So what's the farthest to the left I can go? -4. Yep. It's going to be my h value. What's the farthest to the right I can go? Forever. Infinity. What's the lowest this ever goes? Forever. So negative infinity on my range. That's telling me about my y's. Is there any kind of barrier on the top that would stop it? Nope. So infinity. All right. We're stopping here. We'll pick up tomorrow with the next problem after we do our bell work.